We welcome Mr. Drew Murray from Bruker Nano Surfaces here on our stand of the Quality Engineering. Hello, Mr. Murray.
Hello, Michael. Good afternoon.
Thank you. And let's start with our first question. Which innovations will you present at the Fair Control this year?
We're extremely excited this year to launch the Contour CMM. It's a unique system that can measure the size and the shape of engineering components together with the form and the surface texture and roughness right down to a nanometer level in a single system. The purpose is to characterize small engineering parts, for example, medical implants like hip and knee implants, cutting tools, parts used in the automotive and aerospace industries such as gears, blades, engine components, even down to the optical industry such as contact lenses, where there's a need to measure the deviation from the form of your contact lens, the roughness and the radius of curvature.
You mentioned the optical industries. What is the other target audience for this system?
It's really any precision engineering part that has a size of 10 by 10 by 10 centimeters or less. What you're able to do is to program in the part dimensions using a computer-aided design drawing made by the engineering designers, then measure it based on the known form, and then calculate the deviation from specification from each part. So for example, if you had a medical implant and it had come out of the body and been retrieved and there'd been a failure due to wear, you're able to identify exactly where on that hip cup or hip ball the wear has occurred, and then take that information back to design the next generation of implants, improve the longevity and the yield of these sort of components.
And what new developments do you foresee?
So really looking more broadly at the industry, we see industry gradually moving away from approaches that use contact-based techniques such as stylus systems that have the potential to scratch and typically only acquire a single profile across a component to characterize its roughness or geometric dimensions, on towards an optical methods that allow you to very quickly measure the full three-dimensional properties of the surface in a completely non-destructive and non-contact method, increasing the throughput, bringing this sort of technology to be faster, more in line, and to really more seamlessly connect with the design drawings that were originally used to create the components.
Thank you. And how do you think the market will develop? Any visions?
I think it will develop. Metrology and measurement at a small scale will become increasingly critical, because as we see actually for several years now, from starting with the semiconductor industry and Moore's law, now right through to precision engineering, automotive, aerospace manufacturing, components are getting smaller and smaller, tolerances are getting tighter and tighter. So it becomes increasingly critical to add a higher level of measurement and metrology into the design for manufacturing. So this is where we see it being very important to make these non-destructive measurements, link them to the original design drawings, and identify the deviations from specification using the Contour CMM system.
Thank you very much for this information. Thank you very much, Mr. Murray, and nice to see you.
Thank you, Michael. It's been a pleasure.